Hello everyone! In this video I'm going to show you how the photo etching process for making printed circuit boards works like. The first step is to use a software such as Eagle or anything else like this to design the schematics of your circuit. This is a very simple bridge to connect a microcontroller to a serial port. To do so I'm using a MAX232 IC, which is specifically for this kind of task. Second step, naturally, is to design the board itself. I'm doing this in Eagle. As you can see, everything is designed in reverse because you are watching the board from above. Then you want to make a test print on regular paper. This is a very simple, there is a very simple reason for this. The idea is to make sure that you can fit all your components onto the test print before actually wasting expensive paper on it. As you can see here, I'm just laying down the IC itself and the capacitor. Usually just one IC is enough to see if it fits or not. This is because you are going to print on transparency paper, which is somewhat more expensive than regular paper. So you want to be sure that the whole thing works and fits. When everything is fine, it is time to print. I'm using an inkjet printer because I found that it gives me an higher resolution than my laser printer. So I'm telling it to print as if I were using ultra glossy lucid photographic paper, which is not true because I'm printing on a transparency, but it's the best way to get the highest resolution. I'm also instructing it to print in black and using the photo RPM quality without high speed. I have no idea what photo RPM is supposed to be like, but it gives me very dark and contrasty quality of print. I'm also bringing the contrast up to the maximum in order to get the thickest black I can get. This is fundamental because we're going to use the printout as our mask, so we want it to block as much UV light as possible. To summarize, these are the settings which will be different depending on the printer model and the drivers you're using. So when everything is fine, we are just printing. As you can see, this is a transparency. This is a specific inkjet transparency. It is different because one side is rough and the other side is smooth. You want to print on the rough side. This is because it catches the ink much better. So this is going to take a while and I'm going to speed the process up. It is fairly impossible to actually see the print as it's coming out, so don't even bother losing time trying to look into the printer because the paper is transparent. It's better to check that everything you've done is right, as I'm doing here. Make sure that everything is correct and don't make my same mistake, because I had designed one of the capacitors the wrong way around. I only found out after soldering actually. So this is our board. This is, you notice that I've cut it using the Dremel tool. One side is just, well, the usual, what you would expect, and the other side is covered. This is a sticky protection that you actually peel off before exposing. You can even see the reflection of my camera on it. So while this thing is printing, let's just, oh yeah, here it is. Let it still for a few seconds before picking it up, because you want the ink to dry up. Depending on the printer, it might be very wet, very moist, so just give it a few seconds. Now, as you can see, it is not exactly covering. You can see through, and you can see that there are some little spots. That's what makes it coarse. That's perfectly okay, especially on a ground plane like that. They're really microscopic, so it's not a big deal. It is also not a big deal that our print is not exactly covering. It is not solid black. I found in my experience that this is perfectly okay as long as it blocks UV light compared to the blank areas anyway. This is my exposing machine. it looks like a scanner. It was a scanner. I just removed everything and replaced it with 4 UV neon tubes. This is a potentially dangerous device. You don't want to look straight into the tubes. Actually, these are the same tubes used in bug zappers. There is a sheet of tin foil on the bottom to increase the light even more. As you can see, these are called black lights. Just make sure you don't stare into this. This is the UV light you want to use to expose your board. Before we can expose, we have to cut our printout to size. Make sure that you leave some area, some padding around the circuit itself, because we're going to use that area to stick the whole thing to our board. You need to apply a lot of pressure, so make sure you use a magazine under your sheet of transparency so you don't cause any damage to furniture or anything like that. As you can see, I'm leaving a generous amount of space. At the end you might have to just, take it away like that. Snatch it away. There it is. What you cannot see here is that I'm using a glass frame from a very cheap photo frame that I bought for a couple of euros. This is because we're going to make a sandwich, basically, with all the things that we need. So I'm using Scotch tape to position very firmly the print out to the glass. Make sure that the thing is as flat as it can be. You have to be paranoid in this case, because every minor bump will result into an uneven image, because it will just cast shadows. In fact, I'm having the printed side of the sheet above, so my board will be directly in touch with it. I realize that this might sound overkill, but I have damaged a few boards by having an exposure that was not exactly proper. A good way to see if it works properly is to try and lift it with your finger or your nail. If you have left any bumps, it will be very easy to notice. So when I'm sure, I'm going to apply the last piece of Scotch tape on the empty side. Now here you might notice a few bumps, but this is really minor in this case, because you are going to use a lot of weight on this, and this is the result. At this point, it is time to position our board. First thing to do is peel off the protection layer, as I'm doing there. Be careful to avoid touching the photoresist, which is the green thing that covers the board, with your fingers, because the natural grease that you have on your fingers will damage it and make it basically useless. So you're going to test whether it looks correct, and by keeping it straight, or as straight as you can be anyway, you apply generous amounts of Scotch tape, again trying to make it as tight as you can be. As you can see, I'm applying several layers of Scotch tape arranged in a grid fashion. This is because I found that in my experience this is just the best way to keep it in place properly. So you want to be as generous, as I said, as you can be. This is an investment rather than a waste, so go for it. It depends on the size of the board, how much you actually need, but I found that it's best to exaggerate. It's better to err on the too much side rather than on the too little side. And there we go. Everything seems fine to me in this case. Don't bother too much about the positioning. As long as it's tied and sealed, it should be okay. It will be okay. So let's expose. Exposing a board is a matter of trial and error. You have to find out the correct length of time for your exposure, just like you have to expose a photograph properly to have good results. In any case, a very important step is to have, again, the whole thing as hard pressed as possible on the surface. So I'm using a stack of heavy books. I'm using a big one to have it lay flat on the board itself, and 4 books of that kind, as you can see. That's a medical guide or something like that. When everything looks fine, it is simply time to just start the whole thing. So I'm turning off the light in this case so you can see the way it works. In my experience with my setup and with the boards and with the lights I'm using, basically, I found that an exposure time of 60 seconds, that is 1 minute, is fairly good. So I'm starting the stopwatch on my watch, and you can just, well, do whatever else you want, whatever else you can do in 60 seconds or whatever your time is. If you're using another UV light source, such as even the sun itself, your timings will be much more extended. It might take up to several hours to expose this thing using a regular light bulb or the sun itself. So as you can see, we're close to 1 minute. Well, you cannot really see it, but yeah, there it is. Of course, in this case, it doesn't matter whether you keep it exposing for 2 more seconds or 2 seconds less, as long as you are within the range. Obviously, if you're using a longer exposure time because you're using some other source, the range will be much wider. 2 seconds within 1 minute are much more important than 2 seconds within 2 hours. So that is our board, and we're going to remove it, and it seems like nothing happened. After correctly removing the whole thing, which we're going to do, I suggest to do this very carefully. So you only remove the scotch tape on top of the board itself. This is because so you can keep it handy if you want to make another copy of the circuit, or if something goes wrong and you have to do it again on another board. This is what's happened to me, because in addition to messing up the positioning of one of the capacitors, I also ruined the whole thing during the development the first time. So this came actually very handy for me, because I just had to cut another piece of board and reposition it and redo the same thing. Again, make sure you didn't touch the surface, only hold it from the edges. After exposing, you might want to check the results against the light. You will see a very faint yellowish trace of your board. You will not even be able to discern the details, but it means that it's been exposed correctly. So once the exposure has been done properly, it is time to move to the developing of the board. To do this, you're going to use a solution of water and caustic soda. The great book of photo etching will tell you that you have to use exactly 1 liter of water and 7 grams of caustic soda. My suggestion is forget it. You need around 1 liter of water and around 1 teaspoon of caustic soda. As this thing is toxic, I'm not going to use a real teaspoon. I'm going to use a plastic teaspoon, so no one is going to eat from it. Once you mix it, you have to keep stirring, as I'm doing here, because this thing gets very sticky to plastic in my experience. So just keep mixing until the whole solution becomes clear again. And you might notice that the temperature is increasing a little bit because this reaction is exothermic. The truth is that the increase in temperature is very limited, so you might not even notice it. You notice that I'm using gloves, the kind of surgery gloves. This is not strictly needed. It is very well advised, and I suggest you do that. As you can see, as I just splashed the whole thing, it will immediately begin to develop. And I kept using my fingers directly. Now, you might notice that I'm getting quite anxious. I am quite anxious because to me this is the most complicated part of the whole photo etching process. It is to get it right. In fact, the first time I overdid it, and I had to throw the whole board away because you just wanted to develop the photoresist itself on the areas where it is not supposed to be, which is where the mask was not available, that is in the blank areas of your original printout. So what I do here is I just keep rinsing it in fresh water and keep it into the solution, you know, back and forth. This is very, to me anyway, this is just trial and error, and depending on the board, on the complexity of it, it might take longer or it might take less time, so you cannot really rely on any measurement you did before. So I just keep doing it, and once I have obtained a sufficient removal of the photoresist on the blank areas, I will just stop because I don't want it to eat out the photoresist where it is supposed to be. Because remember, it is the photoresist which is used as a mask during the actual etching of the copper. So let's just speed the whole thing up for the sake of keeping this short. At the end you will notice that the area where the resist is remaining, you will see just a very faint trace of your circuit. Not as faint as it was at the end of the exposure, but it's still quite faint. You might expect something very strong, but it's not. And this is perfectly normal. This is what you're going to remove at the end. So this is our circuit, and as you notice, the text is now correctly written. Now to the etching. This is this is the most dangerous part of the process. As you can notice, I'm wearing thicker gloves because you don't want the stuff to get on your skin at all. So I'm rinsing the whole thing properly, and as you have seen as I was passing there, I also had a mask on my mouth because you don't want to breathe the stuff in. This is very dangerous. I'm also wearing, I don't know the English word for it, but it's a protection for my eyes. So I'm rinsing the whole thing properly, and I'm using a solution of hydrogen peroxide and chlorhydric acid, also called muriatic acid. What I found is that 3 parts peroxide and 1 part acid works fine. I'm doing this actually twice, so this is more like 6 parts and 2 parts. This is because the mark I had made on the small container there that I'm using to pour the whole thing, well, it's just too small. So I'm doubling the dosage, keeping the percentage of the whole thing together. So the peroxide is not dangerous in itself. It's the same thing that you use to clean your wounds. The muriatic acid I'm using is the higher concentrated version. It is at 33%, not 15% that you can find more easily, but it's just as easy to find anyway. This thing is very dangerous on its own. You will find yourself brutally scared and burned if this thing alone touches your skin. So you want to be very careful when pouring this, and always pour acid into peroxide, not the other way around, because this way you're pouring less acid into more peroxide, so the atoms have more time to bond together, or something like that. I don't know much about chemistry, but this is what's been told to me, and I believed it blindly. So I suggest you do your own research. Don't trust me, because I don't know anything, but just, be very careful when you're doing this. Just as a disclaimer, I take no responsibility in case you kill yourself or do something wrong with this. Now, as I immediately put this into the solution, you might have seen that the photoresist itself has oxidized immediately. As you can see, it just changed its color. And as I keep moving the whole thing, this is one thing that's going to take a while. As I keep moving this, the solution is going from clear to kind of green. It's sort of cyanish green. This is because we are oxidizing the copper, or rather the copper is getting into the solution as an oxide. And as you know, if you have anything copper in your house, copper turns green when it's covered by oxide. Now, I don't know the details, I don't know much about chemistry, but I suppose that copper oxide is just green, simply. So, at first nothing will happen. You'll just find yourself wondering, is this working? And it is going to work, just give it some time. In this case, we have very little copper to remove because there is a huge ground plane, so it is quite quicker. For bigger boards, you can find yourself doing this for 10 minutes or so. And this is not very pleasant to do in a warm climate or on a hot day, because you are wearing this mask and this clothes and you're trying your best not to breathe the stuff in, so it's quite tedious, but it's worth it. You will notice that it starts eating the whole thing, because one of the corners or two of the corners will start being, they will just turn transparent. That's when the copper gets away, basically. You see the board itself. So let us speed the whole thing up for the sake of the explanation. What happened in this case is that the etching happened all at once at some point. I suppose that it just has to reach a threshold or something like that. I don't know the scientific explanation for this, but just keep going. You want to keep going. There is no risk of this happening the wrong way. I mean, this is not going to eat out the masked area if you have done the exposure properly. So this is our board, free from copper. Here I'm just inspecting it to see if it's the case to keep going, and it was the case, because one corner just didn't work. It's not major, I wanted to make it as clean as possible, but I realized that it would have been quite pointless to try to get rid of that, because it was just an extension of the ground plane, so it wouldn't have done any harm. Very important thing to remember in this case, or at this point rather, is that this thing is still covered, has been in this toxic and deadly solution for a while. So before you take this with your bare hands or you show this to anyone, you want to make sure that it's been washed properly. Maybe the area which didn't come off was because I might have touched it with my finger as I was exposing it. As you can see there, I'm trying to clean it with my thumb and it's not coming away, but this is fairly okay, so I'm going to rinse it in water. And here, yeah, I just want to be as precise as possible, and just didn't do this because this is pointless. I mean, you have to sign the whole thing, so you know whether it makes sense or not. You're not going to look for a professional board with any of this, so you even want to make sure that your traces are wide enough and all of that. So at this point I finally gave in and I started pouring water in this. As you can see, water makes the whole solution much less dangerous because it becomes clear pretty much. So keep it going for a while. In these concentrations, it's perfectly fine to use your drain to get rid of this. If you were to do this professionally, you would want to collect it and call someone to pick the whole waste and dispose of that properly. So here I just keep doing this. I keep rinsing and rinsing. Just use water as much as you need. Don't be a cheapskate when it comes to this. This thing has been in a toxic solution for several minutes, so you want to have it properly cleaned. Also, make sure that you wash your gloves before you remove them, so you don't touch the side that's been in contact with the bad thing. As you can see, I sort of struggle to remove the thing, and here I use just paper tissue to dry the whole thing up. Now what you see is this is not copper, this is photoresist. In order to see the copper, we have to remove the photoresist. Photoresist is a weird thing because it's very resistant to the deadly solution, but it's very weak when it comes to solvents such as acetone or alcohol. In this case, I'm using just a cotton with some alcohol on it. You can use a cotton swab, the same kind you use to clean your ears, with acetone if you wish. I just happen to have this handy, so I just use this. Some people do not clean this until they have drilled the holes. I'm very... I just wanted to see the whole result, so I just went for it. The people who wait claim that it gives a better protection when drilling the holes. I think that it's really not important because you're going to remove this anyway and you're not supposed to cause damage when drilling the holes. So this is our final board. As you can see, it came out fairly beautifully because you can even see the text, which is very thin. I am not sure, I don't know how thick the lines would be, but it's very thin. And you can see my name, TTL RS232 bridge, and the date very clearly. It's amazing. I was amazed at the result. Now you can see a few hairs of the cotton that I used, but as you can see, this is perfect. You might notice that there are a few spots of removed copper. This is caused by the transparency paper, which is slightly rough on one side, as we have noticed shortly after printing it. This, as I said earlier, is really not important because we have a huge ground plane and the spots are so small that they would hardly mess up even the traces themselves. Of course, make sure you use thick traces. Make sure they are as thick as they can be without touching each other, and make sure they are easy to solder on. This is one mistake. I have to redo the whole board because I wanted to make this as complex as possible, but I didn't realize that it's very hard to solder the whole thing properly. Anyway, moving on to the drilling, I'm using a Dremel tool with very fine tip. This is 1 millimeter. You could even go for 0.8 millimeters. Make sure this is a vertical stand, and make sure that you get this as right as possible. Another mistake I made is that I kept also not only the traces but also the pads quite small, and I didn't realize this until I had my solder iron in my hands. You want to use a fairly high speed for the drilling, and you want to touch the surface before you actually go and drill. Now, I had another problem here because the tip kept slipping into the tool as it came down. I have to fix it. It seems it was just not as tight, so, and I didn't have any tool to make it tighter, so make sure that you do this properly. The reason for having high rotational speeds, is that the faster it is, the cleaner the hole will be. And especially when you're drilling small holes in very tight area, you want to have them as clean as possible, because you cannot use a file to smooth them. So get it right from the first try. And as you can see, the tip practically slipped all inside the thing. In any case, make sure you have other drilling tools. Now, as you can see, you didn't have to get them totally right necessarily, as long as you still have some copper around the hole to hold the solder. Make sure you have other tools, because you might need to drill bigger holes too. So either you have several tips, or you have other tools available to drill the bigger holes, as you can see. And this is what it appears like. This is the component side. This is where you're going to stick your things. Make sure you mark down the position of polarized components and the first pin of any IC you're going to use. Now, the last thing to do is to make the surface rougher, because this makes it easier to solder on. As you can see, this is very shiny. So we're going to use this, just a sponge with an abrasive side, and we're going to simply rub the sponge on it. Just be as violent as you can be. You're not going to cause any damage, and it's actually going to make it easier to work on, so go for it. This is just debris from the sponge itself, not from the board. And it is really hard to show the roughness, the scratches on camera, but you have to scratch it until it's visible, basically. It's just not very easy. As you can see, you can even use your finger to apply more pressure. You're not going to damage anything by doing so, absolutely, so don't worry. And this is a very important step in my experience, because it makes it really easier to let the solder work in it. Otherwise, you might, as you can see, the stripes from the scratching are quite visible. If you don't do this, you might have to use excessive amounts of solder flux, and you don't want to do that. As long as you have solder with flux inside it, it should be enough. You shouldn't have to use additional flux to make the solder stick to the copper. So once you're done, this is your final board. So what's left is just taking the components and soldering away. Just one word about what I'm using to drill the holes. This is an original Dremel workstation, or vertical stand as I call it, with a non-original Dremel tool. This is just the same. It's made by McAllister, and all the accessories work perfectly with this one. So I actually have two of this. So this is what I use, and I hope that this little video will enable you to make your own circuit. Have fun and enjoy it. Thank you for watching.